Okay, so now that we have some definitions out of the way, let's go do some homework-like problems. So essentially this is what your homework is going to look like. I'll walk you through some stuff heavy on definitions. Just use it and go from there. So in the first round, what I'm basically asking you to do is to sketch the following angles in standard position. So remember, standard position is where the initial side is along the x-axis. And again, without a protractor, we're doing our best estimate. So you don't have to be exact. Ballpark figures are fine. If you do have a protractor, I guess, pull it out. But for 20 degrees, right, so here's the x-axis, here's the y-axis. So my initial side starts along the x-axis, and then we go through about a 20-degree rotation. So it's not much, all right? And so there's my best estimate of a 20-degree rotation, right, positive. 210, I think we saw that in the video, but let me go ahead and do it again. So again, we're going to be talking about X and Y. We're starting in standard position, right? We're going to go through a full half rotation. There's 180 degrees, and to get to 210, I need to go about 30 more. So there's my rotation. So right there is 210 degrees as I rotate it around. So the initial side and the terminal side. So there's my rough estimate of a 210 degree angle. All right, and again, positive means we rotate counterclockwise, and then negative means we rotate clockwise. So 300 degrees, negative 300. So again, we're going to start along the positive x-axis. If I rotate here, that's negative 90, negative 180, negative 270, and then I got to go about 30 degrees more. So that rotation that I just went through roughly is your negative 300 degrees. Okay, and then the concept of coterminality angles, right? There's a coterminal angle here, right? We kind of don't forget that idea as well, but definitely there would be my picture of negative 300. We are rotating clockwise, right? And we're going 270 degrees and then about 30 degrees more from the y-axis, and that gets it going. Negative 135 degrees, again, the same thing. We're going to be rotating clockwise. And my initial side again is along the x-axis. If I go a half rotation, I've gone 180, and so we're definitely going to go past 90, but not quite 180. And I think from our discussion, we know that 135 is basically supplement to 45. So we've got about a 45-degree angle there. So, but the angle itself is this guy right there. So there's the negative 135, and then there's like a 45-degree angle right there that's formed between the x-axis and that to kind of give us a little bit of reference. So I'm trying really hard to draw that angle about halfway through, all right, to represent 45, 45, 90. All right, but overall, there's your rotation for negative 135 degrees. Negative 75, so again, we're rotating clockwise, right, but we're not going to go a full a quarter rotation. Negative 75, probably if we rotate it, will probably be really close to about right there. All right, and so there's the negative 75-degree angle at that location. And then last but not least, 150. Again, we're going to rotate. There's my initial side. We're going to rotate all the way to about 30 degrees left of the half rotation. So there's a little 30-degree angle in there. But there's the 150 initial side, terminal side. And so again, we're looking ballpark figure. If you have access to a protractor, knock yourself out and be nice and perfect. But on quiz questions, if you can, get me to a rough estimate of where you're at, I'm satisfied. All right, so we'll go from there. Just as long as you have kind of a general picture. Another definition we went through is complement and supplement. So remember, for complements, we add together and get 90 degrees. For supplements, we add together and we get 180. So what is complement to 25 degrees? Well, we're basically asking ourselves, right, what can I add to 25 to get 90? And if you did a quick subtraction, right, I think we end up finding that that would be 65 degrees. All right, in terms of a supplement, we're asking what can I add to 25 degrees to get 180? And of course, if we just did a quick subtraction, we find that the supplement, I believe, let's see, 170, 160, 155 degrees would be its supplement angle. All right, and on and on. I'm going to skip 75. I'll let you guys do that in Canvas. But, even if we had some quirky-looking decimals, the definition remains the same. So what can I add, right, to 49.7 degrees to get 90 degrees? All right, and so basically we have to do the little subtraction of 49.7 degrees. All right, and so I think when we do that, you know, again, calculator might be handy here, but we've got what, 90, 80, 70, 60, 50, and then it looks like we're about 40.3 degrees, all right, is what would be the complement. All right, if we want to look at the supplement, we have to figure out, well, what do I add to 49.7 degrees to get 180? Again, if we did a subtraction, we'll get the idea. You can break out a calculator, but you know, 180, let's see, 170, 160, 150, and then so it looks like we're what, 150.3 degrees, right? We'll get the job done there. All right, and so there's basically that. Again, I'm going to let D also be a canvas work, all right, just to save a little bit of time. I'm hoping you guys get the idea. Supplements, again, we add up to 180, so what gets me there. Complements, what adds up to 90, and also what basically gets me there. All right, and then last but not least, what a way that I could probably make this a little more difficult or harder, if you would, is to give you a picture like so and ask you to find the value of x in the picture. Right, and when we take a look at that, we notice that the angle right here that is represented by x minus 10, and the angle right here that's represented, right, it's right in there is by 2x plus 1. They basically add up to 90 degrees. So we're basically looking at a complement situation. So 2x plus 1, right, if I add that to x minus 10, what I should get is 90 degrees. Right, so that this picture is complete. It's basically a picture of complementary angles. And so doing the math, right, so we've got 2x and x gives us 3x, plus 1 and minus 10 gives us a negative 9, right? And so it's just basically back to our review where we were solving equations. So I think that's 3x equals 99, divide everybody by 3, and it looks like x is going to be 33 degrees, right, or basically 33. Because the degree is already in the thing. So in order for that to be true, x needs to be 33. All right, and of course, if you did the math here, I think that's 23 degrees, and 23 and 23 would be, or excuse me, 30 to 67. So 67 and 23 are complements, which we know to be true. Last but not least, we're 7 minutes into this, so let me wrap this up. I've got two angles given by expressions, and all I'm telling you is that they're supplements. So again, we just need to fall back on what it means to be a supplement. That means we add up to 180 degrees. So that means this angle given by that expression, if I add it to the other angle given by that expression, it should equal 180 degrees, right, if you want to use your degree symbol. So it's just basically another linear equation to solve, I guess. If we collect the x's, we get 6x plus 8 equals 180. If I subtract 8, we get 6x equals, I believe that's going to be 172. Divide both sides by 6. I don't know if that goes in cleanly. I know 6 goes into 17 twice with a remainder of 5, 50. Yeah, it doesn't. So 8, 28, and let's see. 6 goes into 17 twice, remainder 5, 52, 8 times remainder 4. So 28 and 4, 6, which basically reduces to 28 and 2/3. All right, I hope I did my math right there. Okay, I'm pretty sure. All right, so there's basically our x value for B. We're almost 9 minutes into this, so how about I cut it off? We actually obviously have more homework problems to do, so I'll pick up that story in another video so we can kind of stop this one. See you then.